In this video, we are going to learn the process of deploying a microservice-based application in a Kubernetes cluster and how Google Kubernetes Engine can leverage the deployment process. For this video, I'm going to use a very well-known and simple voting application that is based on microservice. The voting application is hosted in my GitHub repo, which consists of 5 Docker images that are also hosted in my Docker Hub repository. Here is the basic structure of the microservice application. As I told you before, this application is based on 5 Docker images, and each of these images represents a microservice. For example, there is an image that represents a front-end web application developed in Python through which we can give our vote, a Redis image that is used to collect votes and cache them in memory. We will have a worker image written in the .NET that processes the votes collected. Then there is an image for PostgreSQL database that persistently stores the result of the voting. And finally, there is an image written in Node.js that shows the results of the voting in real time. So that's all about the microservice application that we are going to deploy in Google Kubernetes Engine and explore different aspects of Kubernetes cluster. First, let's clone this voting application from the GitHub repo into our Cloud Shell environment, and then move into the application we just cloned. Let's check what exists in this directory. We can see that there are a bunch of files. Some are used to create deployments, and some are used to create services. Before we deploy this application into Kubernetes Engine, first create a namespace called voting with kubectl create namespace command. Without executing this command, we can't deploy our application into the cluster because our application will depend on this namespace. Now it is time to deploy our application into the cluster by just typing kubectl create command, followed by option F, and then a dot. Here, dot means we are going to execute all of the files from this directory. If everything is okay, then we will get confirmation like this. If we check what resources has been provisioned in the cluster with kubectl getAll command, then we can see we have 5 deployments, 5 pods, and 4 services. From the services section, we can also see out of these 4 services, 2 services use load balancer type of service, whereas the rest of the services are based on cluster IP. If we see the external IP of the load balancer type of service is still in pending state, then we wait for a couple of minutes until those external IP addresses are provisioned. Now, let's play with the application we just launched in the cluster. First, in the browser, open the voting application using the external IP address of vote service. So this is the front page of our application. Here we can either vote for cat or dog. Let's give our vote to dog. You can also choose cat though. Now we can see the result of the voting by accessing the result page with the external IP address of result service. Here, one thing to be noted. Only one vote is allowed from one machine. You cannot give votes multiple times from the same machine. So what we can do, let's open a number of tabs in incognito mode several times and try to give a vote each time to see the effect. If we want, we can scale up or down any of the microservices with kubectl scale deployment command with option replicas to specify how many replicas we want for a specific deployment. That's how we can deploy a microservice in the Kubernetes cluster with the help of Google Kubernetes Engine. Now let's try to understand the microservice-based application we just deployed that consist of a number of Kubernetes objects, such as pods, deployments, and services. Let's talk about pod first. Pod is the smallest object of any Kubernetes applications. It consists of one or more containers. If we want multiple containers with a tight dependency on each other, then we can package those containers inside a single pod. However, it's a rare case. In our application, we didn't define the pod directly. Instead, we defined the pods needed inside the definitions of deployments. For example, the deployment configurations for database define what image is needed for the database pod and how many of those pods are needed. Similarly, deployment configurations for Redis define the images needed for caching the voting result in memory and how many of that pod is needed. The same way other deployment configurations are defined. Each of the deployment configurations in this application define only one container to be used inside the pods. We also had a bunch of services that are used to expose one application to others. For example, from the definition we can see, database service will be accessible within the cluster at port 5432, whereas Redis service will be accessible at port 6379. On the other hand, there are two other services, one for voting service and another for result service. Each of these two services are exposed to the outside world via load balancer. That means people from anywhere in the world can access these two services through the internet. Now let's see how to interact with the pods that are provisioned in the cluster. By default, each pod in the cluster is assigned a private IP address and cannot be reached from outside of the cluster. If any pod gets failed or not ready, then we can investigate the issues by getting the details of the pod with kubectl describe pod command, followed by the pod name. If needed, we can also explore the issues further by accessing that pod with kubectl logs command, followed by the pod name. We can also use kubectl get events command to further explore what's going on inside the cluster. So that's all about deploying a microservice-based application in a Kubernetes cluster using a bunch of Kubernetes objects such as pods, deployments, and services. In the following video, we are going to learn how to manage deployments with Google Kubernetes Engine.